Okay, we're going to do a group problem solve here. So see what you can make of this one, and then come back and check your answer. So it's asking about a particle moving in a straight line, but they give us this function of velocity in terms of position, not time this time. So we're not able to just take a time derivative and say, okay, dv dt, easy, we got acceleration, because we don't have it in terms of t. So we're going to have to get a little creative with how we do that. We can still use that v equation, ds dt, though, and use that to um, come up with an equation eventually. But this is how we're going to handle that. So if we take ds dt and plug in v, right, so we've got ds dt equals negative 4s squared. We've got s's here, and we've got t's. We want to separate those so we can take an integral, like a partial derivative, basically, and solve for a position in terms of time function. So that's what I've done here. I've taken the negative 4 and multiplied it by dt. So dt canceled here, and then I've got the dt there. And then I've got ds. I'm dividing s squared over that side. Now I've got the t's on one side, the s's together on the other side. Now that's something I can integrate. So I'll take the integral dt over here, the integral ds over here, and I've made those from 0 to t and 2 to s. That was our initial condition, was s equals 2 when time equals 0. So if we integrate that, we'll end up with negative 4 gets a t on it there from 0 to t, so it'll just be negative 4t. We plug in negative 4t minus negative 4 times 0. And then here, the negative 2 becomes a negative 1. We need to multiply it by a negative 1, and then we're left with s to the negative 1, or just 1 over s, same thing, from 2 to s. And so if we plug in s, we'd have 1 over s, and minus, plug in 2, we've got 1 over 2, and we need to keep this negative sign multiplied by all of it, so don't forget that. And simplify a little more, and we've got s on one side of the equation, t on the other. That's almost what we want, right? Really what we want is the inverse of that. So solve for s. There it is, right? That's the beautiful equation that we needed, s in terms of t, so we can solve for velocity. So if we're going to take a derivative of that, we need to remember how to do a derivative when we have a variable in, excuse me, in the denominator. So the denominator is where the t is. So we're going to have a quotient rule, right? Which tells us, the way I remembered it anyways, was low d high minus high d low over the lower function squared. So here we go. Low d high would be 8t plus 1 times the derivative of the high, is 0. So that's not in here. Minus high times d low, so there's the minus, I don't know why it's there, but minus high d low would be 8. So there's the minus high d low part. All divided by the lower function squared. Simplified a little, and there's our velocity equation. We're halfway there. Let's do it one more time for acceleration. This one's slightly uglier just because we have an exponent in the quotient rule now. So we'll also have an exponent rule when we do a d low. But not too bad. We've got negative low d high, which d high is the derivative of 16, still going to be 0. So nothing there. 0 minus, there's the minus, high 16, d low. Ooh, the derivative of the bottom would be this 8 times 2. And then we've got this exponent that we're going to mess with. It's going to end up adding to this bottom part, right? Once we square that, it'll become a cubed. So that's what we'll end up with for our acceleration equation. So might need to brush up on the calculus, if anything, for this one. As far as dynamics new stuff, not too bad, right? We had to rearrange this equation, plug in our velocity, and uh, integrate in order to find a ST relationship. But once we find that, it's just integrating and or taking derivatives. So that is it for that group problem solve.